Students, now we are going to discuss define and explain properties of the system. Last time we have discussed what do you mean by system, what do you mean by surrounding, and what do you mean by universe. System means it is the part of universe which is under thermodynamic investigation that we are calling as a system. After that, we have discussed what do you mean by surrounding. Surrounding means it is the remaining portion of the universe other than the system, that is called as the surrounding. And universe means system plus surrounding, that is called as the universe. Now we are going to discuss define and explain properties of the system. So there are two properties of the system. Number A, extensive property, and number B, intensive property. First of all, we focus on the intensive property and extensive property. So intensive means it is the independent and extensive means it is the dependent. This is the short way to memorize. First of all, we go for the definition. A property which depends on the amount of matter present in a system is called as extensive property. Means we can consider a property which depends upon the quantity of matter present in the system, that is called as extensive property. For example, mass, volume, internal energy, heat capacity, number of moles, etc. When you consider the example of 10 ml of water from the tank, then its mass will be less than 100 ml of water of the same tank. Hence, mass is an extensive property. Means, so extensive property means the property which depends on the amount of matter. Extensive properties depends upon the quantity of matter. If quantity of matter is more, then property will be more. If quantity of matter will be less, then property will be less. For example, 10 ml water, its volume will be less. If you are taken 100 ml water, its volume will be 10 times bigger. Means here mass is there, volume is there, internal energy is there, heat capacity is there, number of moles is there. This depends upon the matter present in the system. If matter is more, property will be more. If matter is less, property will be less. And that is called as extensive property. After that, we are going to discuss the second type of property, that is called as the intensive property. It is totally opposite to the extensive property. A property which is independent of the amount of matter in a system is called as intensive property. The word intensive is having the word in means independent. It is the property which is independent of quantity of matter present in the system. Means whatever the quantity of matter you have taken, that property is not changing. If quantity is more, property will be same. If quantity is less, property will be same. For example, pressure, temperature, boiling point, melting point, surface tension, viscosity, specific heat, etc. It can be better understood by considering the example. Suppose we have taken 10 ml water from the tank and its temperature is 30 degrees Celsius. If we have taken 100 ml of water from the same tank, then its temperature is also 30 degrees Celsius. Hence, temperature is an intensive property. If we have taken the water, 10 ml water from the tank, its temperature is 30. If you have taken 20 ml water, its temperature will be 30. If you have taken 30 ml water, its temperature will be 30. Means quantity of matter is increased, till property remains same, temperature is not increasing. If you have taken the mass, 10 ml water, mass will be less. 20 ml water, mass will be double. 30 ml water, mass will be triple. But in that case, it is independent, and that's why it is called as intensive property. A property which is independent of the amount of matter in a system is called as intensive property. For example, pressure, temperature, boiling point, melting point, surface tension, viscosity, specific heat. Suppose you are considering the boiling point. Boiling point of water is 100 degrees Celsius. You have taken 10 ml water, it will boil at 100 degrees Celsius. If you have taken 50 ml water, it also boils with 100 degrees Celsius. If you have taken 1 liter of water, it also boils at 100 degrees Celsius. means quantity of matter is increase or quantity of matter is decrease, no matter, this property remain constant, and that's why it is called as intensive property. स्टूडेंट, आज हमने पढ़ा इंटेंसिव प्रॉपर्टी और एक्सटेंसिव प्रॉपर्टी. सिंपली इंटेंसिव प्रॉपर्टी मीन्स इंडिपेंडेंट एंड एक्सटेंसिव प्रॉपर्टी मीन्स डिपेंडेंट. सो एक्सटेंसिव प्रॉपर्टी का मतलब क्या है? ऐसी प्रॉपर्टी जो, एक्सटेंसिव प्रॉपर्टी का मतलब क्या है? ऐसी प्रॉपर्टी जो क्वांटिटी ऑफ मैटर पे डिपेंड करती है, जैसे कि मास है, वॉल्यूम है, इंटरनल एनर्जी है, हीट कैपेसिटी है, नंबर ऑफ मोल्स है. हमने अगर 10 ml वाटर लिया तो उसका मास कम रहेगा. 20 ml वाटर लिया उसका मास डबल हो जाएगा. 30 ml लिया उसका मास ट्रिपल हो जाएगा. मीन्स दिस प्रॉपर्टी डिपेंड्स अपॉन क्वांटिटी ऑफ मैटर, इसीलिए उसको एक्सटेंसिव प्रॉपर्टी कहते हैं. उसके बाद दूसरी प्रॉपर्टी है इंटेंसिव प्रॉपर्टी. इसका मतलब क्या है? ऐसी प्रॉपर्टी जो क्वांटिटी ऑफ मैटर पे डिपेंड नहीं करती. इट इज नॉट डिपेंडेंट, इट इज इंडिपेंडेंट ऑफ अमाउंट ऑफ मैटर. जैसे टेम्परेचर है, अपने घर में टैंक रहता है, टैंक में 200 लीटर 400 लीटर वाटर रहता है. उसमें से 10 ml वाटर लिया और उसका टेम्परेचर 30 डिग्री सेल्सियस. तुमने उसी टैंक से अगर 50 ml वाटर लिया, उसका भी टेम्परेचर 30 डिग्री सेल्सियस ही रहेगा. तुमने 1 लीटर भी वाटर लिया तो भी उसका टेम्परेचर 30 डिग्री रहेगा, उसके ऊपर नहीं रहेगा. इसका मतलब तुमने क्वांटिटी ऑफ मैटर बढ़ाई तो भी प्रॉपर्टी वही रह रही है, क्वांटिटी ऑफ मैटर कम की तो भी प्रॉपर्टी वही रही है, वो चेंज नहीं हो रही है. इसलिए उसको कहते हैं इंटेंसिव प्रॉपर्टी. क्लियर? स्टूडेंट्स, now we are going to discuss another topic. What are state functions? So state functions, for explanation we are considering the figure. So this is called as the initial state, this is called as the final state. Here pressure is P1, here pressure is P2, here volume is V1, second final state V2, initial state T1, final state T2, and number of moles n. It may be n1 or n2. Okay, so definition is that a property of system which depends on initial state and final state of the system and independent of the path followed by the system to attain it is called as state function. Means it is the property which depends only on initial state and final state. Initial state and final state. It is not depends upon the path followed by the system. Suppose we are having the pressure. Pressure is suppose 1 bar and it is finally changes to 5 bar. So what happens? Pressure is changing from initial state 1 to final state 5. Okay, but it is not going, 1 will go to the 7, 9 and finally it comes to the 5. We are not interested whether it going to the higher or lower. We are interested only initial state and final state, not on the path followed by the system. That property is called as the state function. Same is the condition of volume. Suppose you are taken the volume of 50 ml and it is changes to 60 ml. So 50 ml is initial volume, 60 ml is the final volume. So we are interested only in initial state and final state, not on the path followed by the system. Such a state, such a functions are called as the state functions. Same is the condition of temperature. Suppose initial temperature is 40 degrees Celsius and it rises to 45 degrees Celsius. Here temperature is increased, but sometime 25 degrees Celsius may become 20 degrees Celsius, it may be decreased. We are interested only initial state and final state, and such a functions are called as the state function. It depends only on the initial state and final state, not on the path followed by the system. That property is called as the state function. For example, pressure, volume, temperature. Consider a change in the state of a system from initial state to final state. This is our initial state and this is our final state. So in that state, what is happening? Here, there is a change in state functions from P1 to P2, V1 to V2 and T1 to T2. So this is our initial state P1, V1, T1 and final state P2, V2 and T2. By 3 different paths, we can go in 3 ways. So this way, you can consider this way, You can consider this way and you can consider this way. So there is a numerous way, but we have considered only three way. But the change in the pressure, change in the volume, you are considering the initial state P1, V1, T1 and final state P2, V2, T2. But change in the pressure is calculated by final pressure minus initial pressure. That is delta P is equal to P2 minus P1. Suppose first pressure is 10 dm cube, 10 bar, and second pressure is 30 bar. So 30 minus 10, it will be 20. That will be change in pressure. We are not interested in that path. We are interested in the final state and initial state. Same is the condition of volume. Change in volume delta V is equal to V2 minus V1. First volume is 1 dm cube, second volume is 3 dm cube. So final means 3 minus 1, it will be 2. Same is the condition of temperature. Change in temperature can be calculated by using the formula delta T is equal to T2 minus T1. Suppose first temperature is 100 degrees Celsius, second temperature is 120 degrees Celsius. So final temperature is 120 minus initial temperature 100. 120 minus 100 means it will be 20. So that change in pressure, change in volume and change in temperature, it can be calculated by considering final and initial state, not on the path. These changes are independent of all the three paths but depends only on initial and final state, and such as functions are called as the state function. State function का मतलब क्या होता है? ऐसे functions, ऐसे properties जो सिर्फ इनिशियल स्टेट और फाइनल स्टेट पे डिपेंड करते हैं, उन्होंने जो पाथ लिया है उस पे डिपेंड नहीं करते, उनको कहते हैं हम स्टेट फंक्शन. जैसे कि प्रेशर, पहला प्रेशर है P1 और फाइनल प्रेशर है P2. इनिशियल प्रेशर P1, फाइनल प्रेशर P2, और मुझे चेंज इन प्रेशर निकालना है तो फॉर्मूला है उसके लिए डेल्टा P इज इक्वल टू P2 माइनस P1. सपोज हमने पहला प्रेशर लिया है 10 dm क्यूब और 10 बार, नॉट dm क्यूब, एंड सेकंड प्रेशर लिया है हमने 20 dm क्यूब और 20 बार, नॉट dm क्यूब. सो चेंज इन प्रेशर कैसे निकालेंगे? फाइनल प्रेशर माइनस इनिशियल प्रेशर, 20 minus 10, it will be 10. Same is the condition of volume.